Hello, good morning, everybody. So, the topic of discussion is going to be wind energy. So, till now, we have done two renewable energy systems, namely solar and MHD. The next in line is going to be wind energy systems. Growing concern for the environmental degradation has, in fact, led to the world's interest in renewable energy resources, and wind energy is one of these. So if you can recall, or if you can have some information related to wind energy systems, people in very ancient civilization, they used to have some kind of wind energy systems for their energy requirements. The ancient systems of windmills have been there since millennia. It is not that something new is happening, just like photovoltaic systems or MHD generation. In case of wind energy systems, we have got a very historical presence of wind-related energy systems, though it was in very crude form, but people used to get benefit from the things that were operational at that time. Nowadays, wind is commercially and operationally most viable energy, renewable energy resources, and accordingly emerging as one of the largest source in terms of renewable energy sector. So it is going to be extremely important that one should have some fundamental ideas about what the wind energy generating systems are going to be. So how can we identify, or how can we define the wind that is the most important part of this wind energy generating systems? Wind is the movement of air in response to pressure differences within the atmosphere. Pressure differences cause air masses to move from a region of high pressure to one of low pressure. That probably all of us know it. And this movement of air is known as a wind. So there is a definite movement of air that is required in order to harness energy out of the wind. So if air is still, it is not moving, then I don't think we can have any meaningful impact on these technologies. So flow of air or wind, there should be some velocity for the wind. Such pressure differences are caused primarily by differential heating effects of the sun on the surface of the earth. Now, as we know that the radiation of sun is constantly occurring on different surfaces of the earth, and due to the atmospheric layers which are present hundreds of kilometers above the earth's surface, and the density of these layers are not even or not very homogeneous, there is going to be kind of different pressure available at different heights. Now, this is going to be the primary cause of wind. So, wind is a natural phenomenon or movement of air across the land or sea, and it is caused by uneven heating and cooling of Earth's surface, and by the rotation of Earth around its axis. So these are the different causes for the occurrence of wind. Land and water areas absorb and release different amount of heat. You should know that the heat absorption and releasing capacity of land and water mass is going to be different. So both land and water bodies absorb and release different amount of heat with different rate that they receive from the sun. As the warm air rises, cooler air rushes in to take its place, causing blow of local wind. It is not that everything is stationary. When the wind or air warms up, it leaves its place to the colder air, and the warm air goes upside in the atmosphere. And this is where probably the flow of air is more prominent, and the occurrence of wind can be happening. So these are the various causes for the occurrence of a definite wind movement. Annually, over the Earth's surface, around 1.7 million terawatt hour of energy is generated in the form of wind. Only a small fraction of the wind energy can be harnessed to generate useful energy. And this, in fact, is going to be a great limitation for harnessing the wind energy, because wind is available everywhere, but we cannot install wind turbine for the generation of electricity everywhere. Unlike the installation of photovoltaic systems on our rooftops, on barren lands, whatever small space is available, we can have different type of solar panels. I might not have told you about the vertical bifacial solar panels. These kind of panels are available, and these are being used in many advanced countries instead of flat solar panels that is so common sight everywhere. Scientists and engineers, they have developed bifacial, I mean the up and down, both surfaces can utilize the radiation in order to generate the photoelectric or photovoltaic effect. So vertical panels have also been installed, but such situations are not going to happen for wind energy systems. So this has got a great limitation. That's why only a small fraction of the wind energy can be harnessed to generate useful energy. Now, many of you might think that why wind energy? Why not solar? Why not other forms of energy? Why should we go for the wind energy systems? Let us first have limitations. One of the main limiting factors in the exploitation of wind power is the competing land use. So it is definitely a great restriction, as I just told you about the photovoltaic systems. In case of photovoltaic systems, we have got the availability of space which cannot be made available for the wind systems. It is simply not possible. So the land use must be restricted, because if we are going to install wind systems, it may hamper our routine daily activities, our space movement, not this free movement around our working environment may be greatly restricted. A 1991 estimate put the realizable global wind power potential at 53,000 terawatt hour per year. And We will very soon have that table also. So before that, why should we rely much on wind energy systems? Why is that the scientists which are working in the field of renewable energies are so curious and so hopeful about the wind energy, just like the solar systems? The first and the foremost thing is that it is highly environment friendly. I mean, nothing is going to disturb kind of landscape that we are going to create after the installation of these wind turbines, wind farms. So only the landscape changes. Otherwise, there is not going to be any environmental impact as far as our environmental system are concerned. And there is a good wind potential to harness wind energy. That is the most important part, that whatever is available, we are not even able to tap it to its full extent. A permanent shield against ever increasing power price. Because of all the increments which are occurring in case of other systems, the cost per kilowatt hour reduces over a period of time as against rising cost for conventional. So in case of fossil fuel based or conventional systems, the cost will always keep on increasing. But in case of wind, the cost is not going to increase once we install the systems for many years. So it is one of the cheapest source of electrical energy. There should not be any doubt about that. At the same time, we can have another important advantage associated with system. It is a kind of project with the fastest payback period. I mean, less and less time is required for the payback period. So payback period is that time at which we attain the grid parity in terms of other competing energy resources. So it has got the fastest payback period. It can have a very fast track power project with the lowest gestation period, and it can be installed once the sites are identified and everything is cleared at all levels. The installation is going to be requiring less and less time in comparison to other systems. Operation and maintenance costs are very low in comparison to other generating systems. As you all know that no marketing risk, as the product is electrical energy. So there is not going to be any risk related to the marketing or other issues like that. At the same time, this project does not involve any investment in manpower. Very less manpower investment or manpower is required in order to operate and maintain the wind energy systems. So these are the advantages which may not occur with other renewable energy systems. We shall keep on learning many such things in our ongoing discussion. So now you can realize that wind energy systems are so useful, and India is not lagging behind in harnessing the wind energy power. So this is a table that was calculation regarding to the available resources. So the wind map of the whole world was taken into consideration, and an estimation was prepared about what are the potential of wind energy systems across the globe. Number one, Western Europe is 4,800 terawatt hour per year. North America, the USA, 14,000 terawatt hour per year. Australia, it is 3,000, Southern Hemisphere. Africa, 10,600. Latin America, 5,400. Eastern Europe, USSR, 10,600. Asia, it is 4,600 terawatt hour. Total capacity is going to be 53,000. Now, this is a huge potential. And a region-wise estimation was carried. So, how does it work? The whole concept of the wind energy systems, it is a form of solar energy. Yes, solar or the sun is going to be the primary cause of the wind occurring and happening around us. Wind turbines convert the kinetic energy in the wind to mechanical power. A generator can convert the mechanical power into electrical power. So in a nutshell, this is how the wind energy can be harnessed to generate the electrical power. The economics of wind power depends on wind speed. Naturally, when we talk about wind, the speed of the wind becomes a very important parameter in relation to the power that we generate out of the systems of wind turbines and generators. So speed will definitely be a very important factor. Now, all said, it is not that the total power output of the wind systems will be directly proportional to the speed. And we can keep on increasing the speeds and getting the higher power outputs out of wind turbines. This cannot happen. As you will see as we move through different slides, that there are certain limitations which govern the power output out of the wind speed. The second is actual energy contained in the wind varies with the third power of the wind speed. Yeah, it is proportional to the cubic. If we increase 2 times, the power output is going to increase 8 times. So there is a different kind of, it is not directly proportional to wind speed. The wind speed has got a very different relation with the power output of the turbines. Double the wind speed and the energy it carries increases 8-fold. Now the location of the sites, what are going to be the best location or the best sites to harness the wind energy systems? So the starting point for any wind development must be a site where the wind is flowing with good speed. Wind speed varies with height. Yes, height plays a very important role, and that is good, in fact, for the establishment and erection of the wind turbines. These are important things because if these turbines are not located at greater heights, it is going to interfere with our normal routine life. So it is always safer, it is always better to install these turbines at good height. The wind speed varies with height. Yes, it varies with height. At the same time, you should know that it does not only vary with height, the turbulence of the wind restricted with height. At low height or at low level, the turbulence, the wind turbulence is somewhat more, and this turbulence is not at all a good factor for the wind turbines. Thus, larger wind turbines, when placed on higher towers, tend to be more efficient. So in general, it is going to be a thumb rule that we can install larger wind turbines, and these turbines must be placed on high towers. Turbulence is not much because of many factors. Now, this is going to be a simple output equation or expression related to the wind turbine power. P is 1 by 2 rho ACP VQ, and these are the constants related to the other coupled systems NG and B. Rho is the air density, and the value is almost 1.225 kg per meter cube at sea level. A is going to be the rotor swept area exposed to the wind in meter square. CP is going to be the coefficient of performance, and it is the maximum efficiency which is possible. 59% is going to be the maximum efficiency possible out of this wind turbine, and this is known as the bed's limit. Normally remains between 0.35 or 0.32 or 0.30 to 0.4 or so. V is the wind speed in meters per second. Ng is the generator efficiency, 50% for alternator, 80% or possibly more for permanent magnet generator or grid connected induction generator. So it will depend on the kind of generator that we are going to couple with our wind turbines. NB is the gearbox, bearings efficiency depends, could be as high as 95%. So all these accessories that are required for tapping the mechanical movement of turbine blades so that power can be generated out of it. So due to all these accessories which are coupled with the turbines, the efficiency depends on. Now we can focus our attention on the wind turbines. So the main components, as we shall see later on, there are many things apart from the wind turbine. Now we can move towards the development of wind turbines. The earliest developments related to the wind turbines were in the form of windmills. Windmills were a kind of system which were based on wind energy, and all different mechanical work was associated with these windmills. It is not that we were going to have the kind of production of or generation of electric power. These windmills were designed for different applications depending upon the requirement of mankind. So they were not directly involved in the generation of electricity. So this is the main difference between a windmill and a wind turbine. Wind turbines are exclusively installed in order to generate electric power. Now, this is a very great, important aspect of electrical engineering that we like to have, or we like to generate electric power in order to do our mechanical systems, electrical systems, all kinds of systems. These systems are powered by electrical energy. Now this gives us a lot of flexibility. Instead of designing the systems based on their operation, like mechanical systems can be directly coupled with windmills, or the things, electrical systems should be coupled with other electricity generating systems. No. First, the energy is preferred to be converted to electrical energy, and all kinds of conversion into different forms of energy can be done with the help of electrical energy. That is going to be the most efficient kind of conversion, as well as cleanest form of operations regarding to different energy conversion systems. The earliest known record is from Hero of Alexandria, who described a wind machine in the 1st century AD. So almost 2 millennium back, the people were aware that this wind can give us lot many power related to our requirement, and they were thinking, they were trying to develop systems with the kind of things were available at that time into forms of windmills and all related accessories. So windmills soon spread into Europe, into the Western Mesopotamia and all these places, even in China. Apart from Europe, where a lot of research and development happened in relation to windmill and turbines. Probably some of you may know that Holland, earlier known as Holland, now the Netherlands, they are a very leading nation with respect to the use of windmills. The wind turbines and systems are systems that harness the kinetic energy of the wind for useful power. Wind flows over the rotor of a wind turbine, causing it to rotate on a shaft. The resulting shaft power can be used for mechanical work. The Industrial Revolution brought refinements to windmill design. The number of windmills began to decline with the advent of steam power. Now, this was a very interesting development that occurred when the Industrial Revolution took place in Europe, especially Great Britain and few other countries. So steam power was developed by utilizing the coal as a fossil fuel. The coal was a very good fuel in the respect that it can be transported over easily to the places where it is not available, and there we can harness the energy which was available in this form of fuel. So definitely it provided us a very good alternative. At that time, people were not very conscious about the environment. So some 200, 300 years after, the debate about environmental degradation started. So when the steam power by James Watt and other scientists, physicists was developed, people find it more convenient in comparison to the, because as you know, if electricity is not able to transmit it from one place to another place, the application of electrical energy will be greatly restricted. So it is because of the transmission ability of electrical power, we are able to popularize the use of electricity. Nowadays, there is no other mode of power other than electricity, which is so popular, so clean, so transportable than the electricity. So because of all these advantages, which we hardly think over, because it is so inherent with the application of electrical energy, and this in fact is the greatest reason to popularize the use of electricity, simply because we can generate it at some other place we can transmit the whole of the energy with very less losses, and we can utilize it as and when we require it. Some storage things are available, many other advantages are available with the application and use of electrical energy. So same kind of thing was occurring at that period also. The windmills began to decline because steam power was gaining ground, and it proved to be very useful due to many reasons. It was during the oil crisis of the early 1970s that modern interest in wind turbines took form. Now again, some 200 to 50 years afterward, the wheel turned the full circle, and because of all the low cost associated with the fossil fuel, all its convenience was put in peril because of the OPEC countries. They decided that they are not going to sell oil as a cheap fuel, they are going to raise the price. And this occurred in 1973, as it is known as the major oil crisis, that brought a very, you can say, kind of great recession in the world economy because of increasing fuel prices. And since everything was based on the low fuel, on the low energy that was available otherwise, scientists and energy policy formulators, they thought that we should now move towards other options for our energy use. And that's why we are seeing a surge in the development and research activities related to the renewable energy, non-conventional energy systems. We have already discussed in great detail during our solar energy discussion. So from 70s onward, again, a lot of interest was created in wind and solar, and thereafter there is no looking back. The early wind turbines till 1980s had generating capacities around 30 to 60 kilowatt. During 1980 to 90, standard turbine size remained between 300 to 500 kilowatt. Now see how the capacity of the wind turbines were enhanced, and these were done with the help of good mechanical advancements. At the end of 90s, a typical wind turbine size reached around 1 megawatt. A single wind turbine can give us 1 megawatt of power. Now this is going to be quite huge in terms of the power output. Now you can compare the same kind of installation capacity with respect to solar photovoltaic or solar thermal energy systems. 1 megawatt is quite high in comparison to the PV systems. For that we need great amount of land. As far as flat panel installations are concerned, in case of wind turbines, if we are able to install it at a proper place, then a single installation of a single unit wind turbine can provide us 1 megawatt of electrical power. So these are something, and this is going to be a 24/7 activity, unlike the photovoltaics or solar energy systems. So a lot of advantages are here on account of wind energy systems related to or in comparison to other systems. A 2 megawatt unit was the most common at the beginning of 2004. In the first decade of 2000 or the 21st century, we were able to build a 2 megawatt unit for a single wind turbine generator set. Larger 5 megawatt units were already in operation with blades of 60 meter in length and rotor dia of 120 meter. So the sizes were huge, but the output was enormous. So the wind systems, they progressed from 30 to 40 kilowatt to 5 megawatt unit till 2010-11, like that. And I had just gone a news item some days back, and it said that Siemens on May 19, 20, they announced that they are going to launch a 14 megawatt wind turbine model. 14 megawatt, just think. 14 megawatt wind turbine model with 222 meter rotor dia, meant for offshore wind farms that can be scaled up to 15 megawatt using a power boost function. Now, this is the latest kind of development which has come from a multinational company which is operating in wind turbine systems. So 15 megawatt of power can be generated out of a single turbine system, and that is a very, very great step in relation to the wind energy generating systems. Though it has not been installed, but within 2 years, they are going to make the plants operational with such kind of 14 megawatt optimized power units. So this was the latest kind of development in terms of the sizing and capacity of wind turbines. So now you can have a very clear formation in your mind that what are the wind systems, how these wind systems can be commissioned, can be constructed, can be installed in order to tap the wind power that is available at different geographical locations around us. Wind turbines are going to be the heart of the wind energy generating systems. They are the most important part. And how the development in the design and operation of wind turbine has come a long way for the future growth of wind energy systems.